Hi, welcome children. Welcome to the discussion of JEE main examination conducted on June session 2022. And today we are going to discuss the paper conducted on 27th June 27th June 2022 and evening session paper. Evening session paper. That is what we are going to discuss, the chemistry part of it. Okay. A warm welcome to the discussion class. Right. So we are going to discuss the chemistry part. Let's go through the first question. There are graphs given. You need to identify the correct graphical representation. The correct graphical plot you need to identify. And along the x and y axis, what given is pressure along the y axis and density along the x axis. Pressure along the y axis and density along the x axis. Everybody know what is the relation derived from ideal gas equation. PV is equal to nRT is equal to W by mRT. Therefore, P is equal to W by V RT by M, that is mass by volume becomes density. Density into RT by M. So this formula is applied in that graphical plot. Very well, everybody know. And you see, the pressure is taken along the y-axis and density taken along the x-axis. Quite naturally, this part will act as the slope of the graph and y equal to mx plus c and c remains 0. C remains 0 means it starts from the origin, isn't it? So y-intercept remains 0. And you can see it is a straight line graph, taken pressure along the y-axis and the density taken along the x-axis, and the slope of the graph will be dRT by m, where the variable commented in the question is temperature. So temperature decides the slope of the graph. So definitely we can rule out the graphs which are given. This is not a straight line, it is ruled out. This is not a straight line, it is ruled out. And what given is B and C, which is the straight line graph. Of course, both are starting from the origin, right? But now there is a difference, T1, T2, T3, which is a greater temperature and correspondingly which is commented along with the graph. So which one will be the correct answer? Greater the slope, greater will be the, greater the temperature, greater will be the slope. So temperature maximum means slope will be maximum. So which one is the answer? You see, here T3 maximum, temperature maximum, the slope is maximum. Here T3 maximum, but the slope is minimum. So we can rule out option C, and the correct answer is option B. Option B is the correct answer. A beautiful question based on the ideal gas equation derived from the ideal gas equation density relation from the chapter states of matter, right? Let's move on to next question. So the answer is option B. Answer is option B. Next. Identify incorrect statement for PCl5 from the following. Phosphorus pentachloride. Which statement is incorrect? First one. In these molecules, orbitals of phosphorus are assumed to be undergoing sp3 dehybridization. Yes, that is a true statement. Known to all, PCl5 undergo sp3 hybridization with the trigonal bipyramidal geometry. It is maintaining trigonal bipyramidal geometry. 3 bonds are in the equatorial plane and 2 bonds are in the axial positions. Right? So first statement is correct. Second statement, obviously, it is correct. You see that the geometry of PCL5 is trigonal bipyramidal. True statement. We want incorrect statement. We want incorrect statement. PCL5 has 2 axial bonds stronger than 3 equatorial bonds. That statement is incorrect and that fall our correct answer. Option C is the correct answer as it is a wrong statement. What is wrong in it? The axial bonds are more elongated and weaker than the equatorial bond. So when we discuss about the axial bond versus equatorial bond, this is longer bond and it is relatively weak in nature. That is why the reaction we encounter PCl5 decomposing to give PCl3 plus Cl2 non to all. Right? So that is the incorrect statement. What about the last one? The 3 equatorial bonds of PCl5 lie in a plane. Definitely, these 3 bonds are in a plane and one vertically up and one vertically down. Right? Simple question based on the structural features of PCl5 molecule. All of you are clear about it. Next one. So the answer is option C. Answer is option C. Next one. 2 statements are given. We have to identify the correct choice. First one, leaching of gold. Leaching of gold with the cyanide in the absence of air. In the absence of air is a wrong statement. It is in the presence of air. Lead to cyanocomplex of Au3 plus. Au3 plus, see, this is wrong and this is also wrong. It is not Au3 plus. It is Au plus. Leaching of gold hydrometallurgy studied in the NCERT clearly. The impure gold, it is interacting with the cyanide solution in presence of air and you are getting the complex AuCN twice minus, where gold is maintaining +1 oxidation state, well explained in the NCERT and all. And now followed by this, we are treating with the powdered zinc where the gold will come out, the pure gold will come out and you are getting Zn Cn 4 times 2 minus. This is what the leaching process, the very famous, the very popular hydrometallurgy, cyanide process, MacArthur Forest cyanide process, right? Globally famous. So statement 1 is wrong. Second statement, zinc is oxidized during the displacement reaction carried out for gold extraction. Zinc is oxidized during displacement reaction. Yes, zinc from 0 is converted to zinc 2 plus. That is the true statement. So statement 1 is wrong. Statement 1 is wrong while statement 2 is correct. Which choice? Statement 1 is wrong, 2 is correct. So option D will be the perfect answer. Statement 1 is incorrect, but statement 2 is correct. Okay, next question. Option D. The correct order of increasing intermolecular hydrogen bond strength. See option A, water less than ammonia given. That is wrong. We know oxygen, which is more electronegative than nitrogen. So hydrogen bonding strength, when you compare water and ammonia, in water it must be greater because oxygen is more electronegative in nature. Okay. So that is a wrong statement. Now when you compare this, that is the true statement. Option B is the correct answer. Where you have more electronegative. No, but there is carbon-carbon. Same, no? It cannot be. It cannot be. Because here we have carbon and carbon. It should be option C then. Why C? We have nitrogen, the most electronegative in the list, maximum. Then we have 2 carbon, but you see that carbon, what is the difference it makes? When you take nitrogen, ammonia, that is maximum because nitrogen is highly electronegative. When you look at the next one, it is HCN, this carbon, and the next one CH4, this carbon. This is sp carbon. Sp carbon is relatively more electronegative. So even though it is 2 carbon atoms, it is based on the electronegativity, we can predict the strength of hydrogen bond. Okay, so hydrogen bond strength, we can rule out option A because nitrogen more than oxygen means you cannot afford to, right? In number 2, this order is wrong. This order is wrong, and number 3 will stand the correct answer. As you can find, the nitrogen most electronegative element in the list, right? And here carbon with hydrogen. Carbon with hydrogen, this carbon is sp hybridized and this carbon is sp3 hybridized. All of you learned sp carbon is more electronegative than sp2 than sp3. So that will be the logical idea regarding the answer of that question. Next one. Answer is option C. Basically, in that system, only one will form hydrogen bonding, that too in the liquid state, that is ammonia, because the other molecules, they are unable to make hydrogen bonding effectively. The order of hydrogen bonding strength is not formed actually. Hydrogen bonding is effectively formed by hydrogen with the fluorine, with the oxygen, with the nitrogen. Okay. And there are rare occasions, chlorine, etc. can form hydrogen bonding. Correct order of increasing ionic radii. Correct order of increasing ionic radii. I am sure you understand the given species are all isoelectronic species. They are all isoelectronic species. If you take say Mg2 plus, if you take Mg2 plus, magnesium, atomic number 12, the number of electron here is 10 electron. So whether it is Mg2 plus or Na plus, F minus, O2 minus, N3 minus, they are all isoelectronic species, isn't it? And now what is the order for size regarding isoelectronic species? All of you know it's depending on the effective nuclear charge. And how we can conclude the answer? Greater the minus charge, larger will be the size. Greater the positive charge, greater will be the effective nuclear attraction, and smaller will be the size. So which will be maximum in size? The one with the maximum minus character. The one with the maximum minus character. N3 minus maximum. So this is ruled out. And the minimum will be Mg2 plus. So minimum will be Mg2 plus and maximum will be N3 minus. So we will be selecting option A. Okay, that's a very simple direct question and a frequently many times came a variety of question. Okay, next one. The gas produced by treating an aqueous solution of ammonium chloride with sodium nitrite. Reaction well explained in the NCERT for the preparation of, there are 3-4 reactions commented for the preparation of dinitrogen, right? This is one among that. Ammonium chloride with the sodium nitrite, you will be getting N2 gas. Option B is the correct answer. Ammonium chloride with the sodium nitrite, you will get N2 gas. And this is how the reaction is occurring. A reaction explained in the textbook, all of you know. You see that ammonium chloride with NaNO2, you are getting ammonium nitrite and NaCl, and ammonium nitrite, when water is removed, you will get nitrogen gas. Ammonium nitrate, you can see 4 hydrogen and 2 oxygen. So when 2 H2O out, what remaining is the 2 nitrogen atom, that is N2 gas. A reaction given in the textbook, preparation of dinitrogen gas. right? Along with the other popular reactions, maybe you are remembering the thermal decomposition of ammonium dichromate, right? The decomposition of metal acids, barium acide, sodium acide, etc. Right. Next one. Again, statement-based question, assertion, reason type question. Fluorine forms one oxo acid. Fluorine forms one oxo acid. Yes, refer NCRT. Only one oxo acid is given for fluorine. Which one is that? It is HOF, hypofluorous acid. Fluorine has smallest size among all halogen and is highly electronegative. Yes, that is the reason. That is the reason why fluorine is unable to form higher oxidation state oxy acids. It is only forming one oxo acid, and that too, it's not existing under ordinary conditions. We are able to isolate only at very low temperatures and all, because fluorine highly resistant to give any oxidation state other than -1, because it is the most electronegative element in the periodic table. So I would say both the statements are true, and probably we can comment the reason given is substantially explaining the assertion. Which choice we will select? Option A. Option A. You see, both are correct, and the reason gives the correct explanation of assertion. Fluorine being small in size and most electronegative in nature, it is unable to form any condition other than the one mentioned HOF. Okay, next one. Answer is option A. In third series, metal having highest M2 plus bar M standard electrode potential. Absolutely no doubt. Absolutely no doubt. All elements in the series, the 3D series, that is the first series, are having negative standard reduction potential except copper. Copper is having positive standard reduction potential. I hope you remember, plus 0.34 volt. That is the value. Only one element is showing M2 plus bar M state. M2 plus bar M potential given positive. All others are having negative values. And the answer is absolutely no doubt option C. And the data is available. Copper having positive value. All others are having negative value. Minus 0.9, minus 0.44, minus 0.76. Copper zinc values we are referring quite often, even in the chapter electrochemistry and all. Okay, right. Next one. F orbitals are half filled and completely filled respectively. Half filled and completely filled ions from the F block elements. That is the question. That is pertaining to a reasonable good interaction which you had with the tabulated information regarding lanthanoids and actinoids, particularly their electronic configuration. I am sure you know which element it is. Option C. You see, terbium, you are having 4F96S2. When 4 electrons are gone, you get 4F7. This 6S2 electron gone and 2 electrons from here gone means you get 4F7. 4F7, F7 means half filled system, right? And now ytterbium having such a configuration, when losing that 2 electron, you get ytterbium 2 plus F14 system. F14 system. So respectively, these two will give that condition, right? Quite frequently, we are finding the electronic configuration based question from lanthanoids, actinoids, and this is yet another example we find many times. Gadolinium, electronic configuration of GD, asked many times like that. So electronic configuration of neutral atoms and ions quite frequently coming. This is yet another illustration for that in this examination. Next, we have to arrange in the increasing order of magnetic moment. In the increasing order of magnetic moment. Very well, we can understand option A having a weak field ligand, option B having a strong field ligand, option C having a weak field ligand, and option D having a strong field ligand. Now look at the option A. Option A, we have iron in the +3 state. We have iron in the +3 state. Iron, you know, atomic number 26, 3d6, 4s2 is the configuration of neutral atom. Now 3 electron gone means you have 3d5 system. It is 3d5 system, isn't it? So the neutral atom configuration 3d6, 4s2, 3 electron out, that is Fe3 plus, 2 electron from here and 1 electron from here gone, so you get 3d5. And now being a weak field ligand, these electrons will remain as such. So there will be 5 unpaired electrons. We know magnetic moment is related to unpaired electrons. So order of magnetic moment will be the order of unpaired electron number, isn't it? So first choice we have 5 unpaired electrons. What about second choice? What about second choice, option B? There also we have same Fe3 plus system. We have same Fe3 plus system with the 3d5, but now the problem is that we have strong ligand. Cyanide is present. So what will happen? The difference between A and B is the difference between the ligand. So what will be the electronic configuration? This one, this is going to be T2G. T2G orbital 1, 2, 3, 4, 5. This will be the electronic configuration, and EG remain unoccupied. Why? Because the difference between T2G EG remain large. The difference between T2G EG remain large. Why? Because we have a strong field ligand. So what happens? The electrons are forced to pair up. So how will be the electronic system? T2G contain 5 electrons. So the 4 electrons will be in the paired situation and only 1 electron remain unpaired. So here we have 5 unpaired electrons. The next one we have 1 unpaired electron. Now what about option C? Option C we have manganese. Manganese in what state? Manganese in the +3 state. Manganese in the +3 state, you know, manganese atomic number 25, 3d5, 4s2. That means 3 electron gone means it is 3d4 system. 3d4 system. There again, chlorine is a weak ligand. So what will be the configuration? This electron remain in the unpaired situation. So the number of unpaired electrons will be 4. Why? Because there is no pairing occurring. Why no pairing occurring? The ligand is weak ligand, right? Now the last one, option D, we have again Mn3 plus situation again, where we have 3d4, but the difference is there is a strong ligand. So what will be the configuration? It's going to be 4 electron, 1, 2, 3, 4. And once again, EG orbital remain unoccupied. Only T2G orbital is occupied because of the large difference between T2G and EG. Now the number of unpaired electron counted to be 2 unpaired electron. So let's have a look at the number of unpaired electron present. Here we have 5 unpaired electron. Here we have 1 unpaired electron, and here we have 4 unpaired electron, and here we have 2 unpaired electron, and the number of unpaired electron will give you the idea regarding the order of magnetic moment. So greater the number of unpaired electron, greater will be the magnetic moment. So which one will be the answer? A should be maximum. A should be maximum, isn't it? So A maximum, we have only one choice. A maximum, we have only one choice. So understanding which is maximum itself gives the answer as option B. Let us examine the other order. A maximum, then is it C? Yes, C, 4 unpaired electron. Then is it D? Yes, 2 unpaired electron. Last one B, 1 unpaired electron. So the number of unpaired electron respectively 5 here, 4 here, 2 here, and 1 here, and that is the reason for such an order. A typical question from coordination chemistry. Okay, next one. Option B is the correct answer. Next. On the surface of polar stratospheric clouds, hydrolysis of chlorine nitrate gives A and B. When its reaction with the HCl produces C, right, we need to identify A, B, C, etc. Another reaction which is expressed in the NCERT. Hope you remember these reactions seen. These reactions are available in the textbook. You see, chlorine nitrate. Chlorine nitrate, when hydrolyzed, what happens? This chlorine with the hydrogen removed as, this chlorine with the OH removed as hypochlorous acid, HOCl. That is compound A. And one hydrogen comes in this position, you get a nitric acid. That is compound B. So nitrate with the water, hydrolysis, you get nitric acid and hypochlorous acid. The reactions are there in the textbook and you can very well see what I have written here. Now, with the HCl, what will happen? This chlorine and this chlorine out as Cl2, and once again you are going to get the same compound B. So what is commented? Chlorine nitrate, upon hydrolysis, you get A and B. Chlorine nitrate with HCl, you get a B and C. So B is a common factor. Nitric acid is obtained. It is regarding the chemical reactions that are encountered, explaining the ozone depletion and all stratospheric pollution area. Okay, next one. So which is the answer? Option A, B, C we want. A, B, C we want. So this is A, HOCl, and then B, nitric acid, and then C, chlorine. Option A will stand correct. Fine. Next one. Which is most stable? That is a question. Which is most stable? No doubt, option A is most stable, as this is aromatic. This is aromatic, and that is most stable, having 4n plus 2 pi electron. There are 2 pi electrons. This is having a 2 pi electron system following Huckel's rule, and it is aromatic and most stable. What about the others? Here you have 4 pi electrons and it is anti-aromatic. Here you have 4 pi electrons, it is anti-aromatic. What about D? D is non-aromatic. This is non-aromatic, while these two are anti in nature. Why this is non-aromatic? Because the 2 carbon atoms you can find, which is sp3 carbon, and it will be out of the plane and doesn't maintain the planarity. Answer is option A. Next. What will be the major product of following sequence of reaction? We are taking N-butyl with the isn't it ethine? Yes, ethine. So what given is N-butyl ethine. N-butyl ethine. That is treated with the N-butyl lithium. That is treated with the N-butyl lithium. So what will happen is this acidic reaction will occur. The acidic hydrogen will be replaced and the lithium will occupy that position, and you will get N-butyl C triple bond C lithium like this, and the hydrogen is released, showing the acidic nature of hydrogen connected with the triple bonded carbon atom. We are learning in the text. And now this is interacting with the NC5H11Cl. So what will happen? None to all, this chlorine and lithium out, isn't it? And this will be connecting with this carbon. This will be connecting with this carbon, and the net result will be N-butyl C triple bond C, N, C5H11. This is what you are getting. That's a simple substitution reaction. Nucleophilic substitution, SN reaction. SN reaction. Now it is treated with the Lindlar's catalyst. When this is treated with the Lindlar's catalyst pelletized charcoal for reduction process, hope you remember, this triple bond will be reduced to double bond. The triple bond system will be reduced to double bonded system. And there is something specific in the stereochemical aspects. What is that? Yes, Lindlar's catalyst will give you cis or trans. It will give you cis configuration. It will give you cis configuration. So the final result should be CC double bond with the 2 hydrogen in the cis position, and here it will be N-butyl, and here it will be NC5H11, and that will be the answer. Which choice we can select? Which choice? Option A, B, C. C is the correct answer. C is the correct answer, as definitely we want a cis product. At the same time, if it is sodium with ammonia, you will be getting a Birch reduction, and that will give you trans product. Okay, next one. Option C will be the correct answer. So 14th question. Product A of following sequence of reaction. What is the sequence given? Ethyl benzene first react with the bromine ion. Ethyl benzene first reacting with the bromine ion. So this is ethyl benzene reacting with the bromine and Lewis acid catalyst. There will be electrophilic substitution reaction, and the major product will be bromine coming at a para position. So what is the product formed? You get para bromo derivative. So that part is over. Now it is treated with the chlorine. Now it is treated with the chlorine and heating. So first reaction is ESR reaction. You know that, electrophilic substitution reaction. Second reaction, what is the reaction? Yeah, it's free radical substitution reaction. This is free radical substitution reaction, and the substitution will occur at a side chain, where over here, over the benzylic carbon, the free radical will be formed predominantly, and there will be the substitution happening, and the product obtained will be this one. You get a chlorine here and bromine here. Is that over? No. Now it is alcoholic KOH, that is elimination reaction. Now it is elimination reaction with the alcoholic KOH. So this chlorine is out, and one alpha hydrogen will be out from here. You will get a double bond over these 2 carbon atom, getting the final product, it seems. That I think is the last step. This is what the final product. Option D. Option D. Yes. I'll repeat. Ethyl benzene, first electrophilic substitution reaction, major attack on the para position. We got bromine at the para position. Then it is free radical substitution, which is promoting over the benzylic carbon, because we know benzyl free radical is pretty more stable. So chlorine is coming there. And now the elimination reaction, this chlorine and this hydrogen will eliminate. You get a double bond over this position to get the answer. Option D, right? Next one. Option D. Now we have a matching list question. So what about the first one? First one, A matches with the, wow, that is Reimer-Tiemann reaction. So this is Reimer-Tiemann reaction. A matches with the 4. A matches with the 4 means option C is out. Now phenol giving benzene, yes, treated with the zinc dust, that oxygen will be removed, you get the benzene. So B with the 3, A4B3 means this is also out. A4B3, that is also out. And now next one, phenol giving benzoquinone. That is also the reaction referred in the textbook. This one also, this will be this sodium dichromate and sulfuric acid, that is C with the 2. C with the 2. So we are confirming our answer, option A. Option A. So first one, Riemann-Tiemann reaction, chloroform alkali. Second one, phenol reduced to benzene with a powdered zinc. Third one, phenol converted to benzoquinone oxidation reaction with chromic acid, sodium dichromate and sulfuric acid. And the last one, what about the last one? That is electrophilic substitution reaction. Phenol with the bromine carbon disulfide, we are getting para-bromophenol electrophilic substitution reaction with the first option, first list. Okay, that's it. Option A. Next. Decarboxylation of all 6 possible forms of diaminobenzoic acid. Diaminobenzoic acid yield 3 product ABC. 3 acids give a product A. 2 acids give a product B. And 1 acid give a product C. So what are the possible 6 diaminobenzoic acid? That is our first point. You see, what are the 6 possibilities? See, you can have diamino like this. You can have diamino like this. Now, the carboxyl group, it's a monocarboxyl, right? Yes, only one carboxyl group is there. Carboxyl group can come here, number 1. Carboxyl group can come here, number 2. See, this position and this position are same. And carboxyl group can come here, number 3. So this position and this position are identical. And one can be here or here, one can be here, and one can be here. So these are the 3 isomers where COOH is available. We were talking about 6 isomers, 3 over. Now what about the remaining? What about the remaining? Let's say, see, we can have amino group at 1,3 position, isn't it? We can have amino group at 1,3 position, that is meta-diamino. Now, what are the possibilities? So here, this and this are same, this and this are same. This is another one, this is next one, isn't it? No, it seems this and this are same. Oh, this will give only 2, right? This will give only 2. You see that? This position and this position are same, right? This and this are same. Now, this and this are same. You see, this is para position of this and meta position of this. And this is meta position of this and para position of this. Also, only 2 isomers. Only 2 isomers. If you take 1,2-diamino, you get only 2 isomers. One at the immediate position and one at the third position. Because the immediate position for this and this position are identical. Now, this position and this position are identical. Now, coming to here, you can have COOH over here, number 1. You can have COOH over here, number 2. Right? And you can have COOH over here, number 3. Now taking this position, these 2 positions are same. These 2 positions are same. You see that? You see that? Ortho to this one and ortho to this one. Para to this one, para to this one. So here you will get 3. So here you get 2 isomers COOH coming. And here you get 3 isomers where the ticked positions COOH is coming. Okay. Now there is one more. It's only 5, no? 6 we want. And this is The sixth one, let us try. We have NH2 here and we have NH2 here. Now here only one position COOH is possible because this position are identical and these two are identical. You see, ortho to this, meta to this, meta to this. So all the positions are same, only one possibility. So you get one substituted COOH position. So finally we get 6 isomers. So that is the main point we need to understand from the initial segment. Now, so 6 isomers are ready. Now let us say 3 acid give product A. 3 acid give product A. So this is the 3 acid which is giving product upon decarboxylation. This molecule undergoing decarboxylation, imagine here you have COOH. Decarboxylation means your product is this one. Once it is decarboxylated, the product will be this one. This is compound A. This is compound A. Now, 2 acid give product B. 2 acid give product B. So, this is product B. This is A and this is product B. And 1 acid give product C. So, this is product C. So, first of all, I was explaining where the COOH are possible so that we can understand the configuration of all 6 possible isomers, number 1. Number 2, now that is decarboxylated. That means COOH is out. So, remaining is only 2 amino group. So, amino group can be 1,2 position, 1,3 position and 1,4 position. Now, what is they are asking? The melting point of C is, oh my God. Yeah, it's simple, no? Melting point of this. See, melting point of meta isomer is minimum. It comes in the range of 60s. While melting point of ortho isomer is slightly above 100 and melting point of para is maximum. It is in the range of 140. And we have only one choice. There is absolutely no confusion being created. This will be the answer, option D. Para isomer will maintain high melting point. And remember, this is maintaining low one in the range of 60-65 range. And this is maintaining a melting point of above 100. It's all depending on the molecular arrangement. See, melting point depends on the molecular arrangement in the solid state. So, melting point for this, I think it is somewhat in the range of 60-65 and this is coming somewhat in the range of just above 100 and this is coming in the range of 140 range. And 140 range we have only one choice, option D. Okay, next. Which one? Option D, yes. What is true about buna-N? Buna-N, a linear polymer of 1,3-butadiene, wrong. Obtained by copolymerization of 1,3-butadiene and styrene, that is buna, yes. Obtained by copolymerization of 1,3-buta, that is the answer. That is the answer. It is obtained by the polymerization of 1,3-butadiene and acrylonitrile, that is vinyl cyanide. We get a buna-N. Right. Next one. C is the answer. We have two statements. Maltose has 2 alpha D glucose units linked at C1, C4 and is a reducing sugar. Yes, correct statement. Maltose is formed by 2 alpha D glucose unit linked at C1, C4 and is a reducing sugar. True statement. Maltose has 2 monosaccharides alpha D glucose, beta D glucose. Alpha D glucose, beta D glucose. That is wrong. Linked at C1, C6 and a non. So statement 1 is correct, 2 is wrong. Statement 1 is correct, 2 is wrong. Which one? Option C, right? First one true, second one false. Option C, yes. And here you have the structure and also available in the NCERT. Sucrose, maltose, lactose, well explained in the textbook. and here you have C1C4 linkage. Alpha D glucose connected by C1C4 linkage, and this functional group is free and it can reduce Tollens reagent. That part of the molecule can open up as the functional group is free and it can reduce Tollens reagent, and it is a reducing sugar while sucrose is a non-reducing sugar. Next. Again matching. Antipyretic. Antipyretic is reducing the fever. A with 3. A with 3. So this is out. Analgesic, painkiller. B with 1. A3, B1, but don't give you the answer. Tranquilizer. Tranquilizer is stress reliever. That is C with 2. So we have the answer option A. Option A is the answer. A3, B1, C2, D4. Next. Twentieth question. The anion gas evolved on reaction with the dilute sulfuric acid. Carbon dioxide. Carbon dioxide. Carbon dioxide. Carbonate. Carbonate will give you carbon dioxide. Carbonate will give you carbon dioxide. So definitely simple one. Colorless gas evolved with the brisk effervescence which turned lime. Option, fourth one. A will match with the fourth one. So these two are out. Now what about the next one? Sulfide. Sulfide. Sulfide is first one. Colorless gas which turn lead acetate paper back. Sulfide with sulfide, you will get hydrogen sulfide. Hydrogen sulfide will give you test for sulfide. Lead acetate paper turned black. So A4B1, A4B1, but we don't get the answer because we have to check the, no, yeah, both are same, both are same. We have to check the next one also. Sulfite, sulfite. Sulfite is second one, C with the second one. Colorless gas which turn acidified potassium dichromate solution green. Sulfite with sulfuric acid, it will liberate SO2 gas. SO2 gas. SO2 gas will turn orange colored potassium dichromate solution green due to the formation of chromic sulfate. So solution turning green. So the answer should be C2 means option D. Option D. A4 carbon dioxide, B1 hydrogen sulfide, C2 SO2 gas, and D. What is D3? Brown fumes. Yes, this is giving NO2 gas, brown fumes, which turns acidified Ki solution containing starch blue. It will turn react NO2 react with Ki turning I2. Yes. Next. That seems section 2 question, right? Yes, section 2 question, section B question, it seems. Right. 116 gram of substance upon dissociation yield 7.5 gram hydrogen, 60 gram oxygen, 48.5 gram carbon. Given that atomic mass is okay, the data agree with how many formulae of the following? Okay, fine. So we have to find out the empirical formula and we have to check how many are matching, right? So how to find the empirical formula in such a situation? We have to find out the, yes, percentage of each element. We have to find out the percentage of each element, isn't it? So how to find the percentage? You know, percentage of hydrogen, mass by total mass into 100, 7.5116. Yes, 7.5 gram hydrogen, 1/16 of the total mass. So you will get percentage of hydrogen 6.5 and that of oxygen, is it 60? Yes, 60 gram oxygen, 60 by total mass into 51.7 and percentage of carbon 48 point, right? 48.5, right? We get 41% carbon. So we have to find out the percentage of hydrogen, carbon, oxygen. then you know how to find the empirical formula. How to find empirical formula? The relative number of atoms, hydrogen 6.5% divided by 1, that is 6.5. Oxygen 51.7% by 16, 3 point something. Carbon also you will get 3 point something. So we can make a conclusion. This is somewhat 112. 112 range. It will be in the range of 1:1:2 ratio approximately. So 1 carbon, 1 oxygen, 2 hydrogen will go for CH2O approximately. CH2O will be the empirical formula approximately, right? So which all will satisfy that? CH2O. What about option A? Yes, that will satisfy 2 carbon, 4 hydrogen, 2 oxygen. So A will satisfy. What about B? B will satisfy 2 hydrogen, 1 carbon, 1 oxygen will satisfy. What about C? 2 carbon, 6 hydrogen. No, this won't. Here, 2 carbon, 4 hydrogen, 2 carbon, 4 hydrogen, only 1 oxygen. Oxygen is not okay. So it is only 2. The compound given A and B will satisfy that empirical condition. It is answer 2. Answer 2. See, the question is how many number from the given choices will satisfy that empirical composition. It is 2. Next. Correct set of quantum numbers. First one is wrong. 3 is not possible. This should be n minus 1. 3, 2 minus 2. This is okay. 2, 1 plus 1. Okay. 2, 2 is not possible. So once again, only 2 possibilities. Choice B and C are possible. A and D are not possible. So the answer is 2. Again, next question. BeO react with HF in presence of ammonia to give A, which on thermal decomposition produces B and ammonium fluoride. Oxidation state of Be in compound A is. That's the question. Once again, this is referred in the text, not in the exact way anyway. You see the reactions you might have seen in the text. BeO with HF and ammonia. You are getting NH4 twice BeF4. NH4 twice BeF4. And this is the compound A. And asking what is the oxidation state of beryllium in that? What is the oxidation state of beryllium in that? See, actually, the question is not that much relevant because beryllium is an alkaline earth metal, will maintain only +2 state. Non-fact. Group 1 alkali metal will go for +1 state. Group 2 alkali earth metal will go for +2 state. It's as simple as that. Anyway, you see that it is NH4 twice BeF4 means it is BeF4 2 minus, right? So beryllium will be 2 plus state as fluorine is -1. Overall -2 means this is +2, right? And this is somewhat the reaction explained in the textbook for the preparation of BeF2. You can refer in the text. Next one. 5 moles helium gas expand isothermally and reversibly 300 Kelvin 10 to 20 liter. The maximum work done is, you know the formula, very popular one, quite frequently dealt in almost all numericals from the particular area. You see that this is the work done equation. Work done is equal to minus nRT log V2 by V1 minus 2.303 nRT log V2 by V1, right? So it will be minus 2.303, N equal to 5, R is equal to 8.314, temperature 300, log 20 by 10. Log 20 by 10, you will get log 2, that is 0.3 over into 0.3 will take you to the answer minus 8630 joules. Minus 8630 joules. The answer required is in joules, right? Answer required in joules. It is 8630 joules. And the formula is one of the most popular formula that we are making use from the chapter thermodynamics, doing the problems on work done and the rated area. Work done minus 2.303 nRT log V2 by V1. Hope you remember the formula. Next. A solution containing 2.5 into 10 power minus 3 kg of solute in 75 into 10 raised to minus 3 kg of water boiling at 373.535 Kelvin. Molar mass of the solute is Kb given, and boiling point of water, remember it is not 373, 373.15. So all data available. Delta TB given, Kb given, mass of solute given, mass of solvent given. Find out molar mass. So delta TB is equal to Kb into mass of solute into 1000 divided by molar mass of solute into mass of solvent. See, all data given, this is given, this is given, this is given, this is given. To find out this, that's all. Direct substitution. And the answer is, you see that? Delta TB is equal to Kb into molality. Delta TB is, how to find the delta TB? Boiling point of water 373.535 and the boiling point of solution 373.15 given in the question. Both the data given. That difference will be the elevation in, this is boiling point of water, this is boiling point of solution. So take the difference, that will be delta TB, elevation in boiling point. That is equal to Kb into molality. And molality will be mass of solute by mass of solvent into 1000 by molar mass of solute. And that is what you are asked to find out. Right? All data given. See, 2.5 into 10 power minus 3 kg, that is 2.5 gram. 75 10 power minus 3 kg, that is 75 gram. Kb value given, all are given. Right? We'll get the molar mass as 45 coming as the answer. Okay, next one. Sixth one. The pH value of 10 power 0.001 molar NaOH is, see, OH minus concentration is 10 power minus 3. Therefore, POH is equal to 3. Therefore, pH is equal to 11. Very simple question. Very simple question. See, NaOH concentration given. That means OH minus concentration given 10 power 0.001 molar means 10 power minus 3 molar. Therefore, POH is equal to negative log of this 3. You get pH is equal to 14 minus 3, 11. 11. Next. For the reaction taking place in the cell, PT bar H2 H plus Ag plus Ag, E0 cell given. E0 cell given, we want to find delta G naught. E0 cell given, we want to find out the delta G naught. What is the formula? Delta G naught is equal to minus N of E0 cell. Right? Only the matter of knowing N, you get the answer. So what will be the answer? This is the equation given, and n is equal to 1. N is equal to, that depends on the stoichiometry. That depends on the stoichiometry. If you are writing half H2 Ag plus H plus Ag, that's okay, right? Otherwise n will be 2. Otherwise n will be 2. Suppose you are writing H2 plus 2Ag giving 2H plus Ag. That will be n is equal to 2. That depends on the n value taken. So n value 1 means minus 1 into E0 into F value 96,500. You will get a minus 51.35. Close integer will be which one? 51 will be the answer. 51 will be the answer. Right? Suppose n value taken 2 means, suppose we are writing H2 plus 2Ag giving 2H plus, if we take like that, it will be 2 times. That is 51, it will come 102. Right? Next. See, there is a temperature rise by 9 Kelvin and the rate constant get doubled. Assuming the reaction to be occurring at a 300 Kelvin, value of activation energy is, Arrhenius equation, log K2 by K1 is equal to EA by 2.303 R T2 minus T1 by T1 T2. So what is T1? T1 is 300. T2 is 309. R value, 8.314 joules. And K2 by K1 given as 2. So it will be log 2.3. So it will be log 2.3 equal to, substitute and find out what is activation energy. Right? The answer to be reported in kilojoules. So it will give you 590.65 joules. That is 59.06 means 59 kilojoules. 59 kilojoules will come out as the answer. So temperature difference is given. First temperature given. You know what is the second temperature. K2, K1 ratio is given. You can find out activation energy applying Arrhenius equation. Next one. Log x by m, log p graph is given. Log x by m, log p graph is given. If initial pressure of gas is 0.03 atm, the mass of gas absorbed per gram of the adsorbent is a value into 10 power minus 2. So we want to find out x by m. We want to find out x by m. See, here it is given log x by m equal to log k plus 1 by n log p. This is the formula. So slope of the line given 1. This is the slope of the line. That is given as 1. That means 1 by n is equal to 1. And y-intercept. This is y-intercept given as 0.6. This is given as 0.6. Therefore, k equal to 4. Log of 4 is 0.6. Right? So, from the y-intercept data, we can understand what is k value. From the slope given, we can understand what is 1 by n. And x by m we need to calculate. X by m is equal to k p raised to 1 by n. K value is 4. What is the pressure value given? 0.03. So it is 0.03. What is 1 by n? 1 by n is equal to 1. We get from the slope. So it is 4 into 0.03. That is 4 into 3 into 10 power minus 2 terms. We need to refer the answer. So the answer is 12 into 10 power minus 2. 12 into 10 power minus 2. Our answer is 12. Answer is 12. 12. And next one. 0.25 gram of organic compound containing chlorine gave 0.4 gram silver chloride in carrier's estimation percentage of chlorine. You know the formula. What is the formula for finding percentage of chlorine? It is 35.5 into mass of AgCl into 100 divided by 143.5 into mass of organic compound. So what is mass of AgCl? It is 0.4 gram. What is mass of organic compound? It is 0.25, and you can find out the percentage over. So that will be 35.5, 0.4, 100, 143.5, 0.25 will take you to a figure close to 40. Take you to a figure close to 40. That is the correct answer, right? Oh, that seems to be the last question. Yes, that was the last question. So section A, 20 questions, and section B, 10 questions, mainly the numerical part of the question, right? That is the paper what we have discussed. JEE Mains, as I told you in the initial, JEE Mains 2022 June examination, which was conducted on June 27th. Afternoon session paper, chemistry part we have discussed now. We'll meet with another discussion class in the next session. Okay, bye, see you.